Okay, this is the second part of the 12.3 notes. The first part dealt mostly with parallelograms. This second part is just a bunch of random geometric theorems to help you solve problems using those theorems. To begin with, though, this first slide right here is just a bunch of overlapping triangles. So we're just going to use that idea of overlapping triangles to figure out what x, y, and z are. So to begin with, the first thing I noticed, though, is that this is marked with one arc, angle 25 degrees, and over here z is marked with one arc. That means those two angles are congruent. They're marked congruent, so z is 25 degrees. So that one was pretty easy to see right off. And then the next thing I notice is this triangle right here, this right triangle. I know it's a right triangle just because it's the other side. This right here is perpendicular. This is marked right, so this is marked right. So inside a triangle is 180. I know the right angle is 90, and I've got 25. So if I subtract 25 from 90, that gets me 65. So angle y is 65 degrees. So I know angle y is 65. I'm going to erase this highlighting right here. So this is 65 degrees. Okay, now I think I will look at this triangle, the other side of the triangle right here. And that'll give me the top angle, because once again, I've got 45 down here, so then that must mean this angle up here is also 45. Okay, don't know if I needed that, but I guess I could be going about it the long way. This angle down here, since this is 20, and I'm looking at this angle right here, guess maybe I didn't need that 45. This angle would have to be 70. Vertical angles, this angle would be 70. And then I have this little triangle right here. That's 180. So that means then if I've got 25 plus 70 and I minus that from my 180, my missing angle x is 85 degrees. So I guess there's lots of different, we could finish this out if we wanted. We know this is 110 linear pairs. Inside a triangle is 180, whatever. Basically, we could find all those missing angles if we needed to. Okay, first theorem is isosceles triangle theorem. So basically it says if the sides of an isosceles triangle are congruent, so that's showing you it's isosceles, then you know the base angles are congruent. That's what it's saying. So over here in your triangle, these are the two congruent sides. These are considered the base angles. This angle up here is called your vertex angle. Okay, so it can be oriented different ways, but the base angles are always part of the legs. So that kind of helps you know which ones are which. And the converse is also true. If you know the base angles are congruent, then the sides are congruent and it's isosceles. Okay, by this marking right here, this is marked and this is marked, so that tells me base angles are congruent, so then I know that these sides are congruent. So if I want to figure out what x is, I would just say 7x minus 18 equals 3x plus 6. Combine my like terms and solve it for x. So x equals 6. Okay, so over here it says triangle CAT is isosceles, and the vertex angle is C. So if my vertex angle is C, then T and A have to be the base angles. Those are the angles that are congruent. And if AC equals 3x plus 8, and CT equals 5x minus 12, find AC. Okay, well, since I know the base angles are congruent, then the sides are congruent, so I'll just put those two equal to each other. 5x minus 12 equals 3x plus 8. Combine my like terms. So 2x equals 20, and so x equals 10. So if I want to find the length of AC, then I would go 3 times 10, which is 30, plus 8, which is 38. So AC is 38 units long. Okay, over here, number 2, it says the measure of angle T is 2x plus 7. So this would be like 2x plus 7 something degrees. And then angle C is 5x plus 22 something degrees. And we're supposed to find angle A. Okay. Well, I know that angle A is the same measure as angle T because it's isosceles and the base angles are congruent. And I know inside a triangle is 180. So I think what I'll do is I'll say 2x plus 7, and there's 2 of those because those are my base angles, plus 5x plus 22 equals 180. And then I'll just solve that for x, and then we'll figure out what measure of angle A is. So 4x plus 14 plus 5x plus 22 equals 180. Combine our like terms. So 9x plus 36 equals 180. So 180 minus 36 equals 144. And divide that by 9. And x equals 16. Okay, so if we're going to figure out what the measure of angle A is, then it's going to be 2. So it's going to be 2 times 16 plus 7 will give us the measure of angle A. So 2 times 16 plus 7 is 39 degrees. So the measure of angle A is 39 degrees. Okay, new theorem. This one's called the exterior angle theorem. So it says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. So what that means is you could pick any exterior angle you wanted. There's a lot of them. But this one right here is angle 1. Okay, its linear pair angle is this angle right here. So what it's saying is the other 2 angles, this angle and this angle, so angle A and angle B, if you sum those 2 together, then it's going to equal the measure of angle 1. And that makes sense because inside a triangle is 180 degrees. And if you subtracted out this green angle, or blue now, if you subtracted that angle out, you would be left with those 2 angles, which would be the measure of angle 1 because that's a linear pair. A linear pair is 180 degrees. So that makes sense. And you could put that linear pair anywhere. So this one says find the measure of the exterior angle. So this exterior angle is right here. So the linear pair that we're working with is right here. So, well, here's the exterior angle. This would be the other half. The linear pair would go right here with that angle. So the theorem would say then that 42 plus x plus 28 has got to equal the 2x minus 5. So if we want to figure out what x is, find the measure of the exterior angle, we're going to have to find x. We just need to combine our like terms. So we've got 42 and 28, so that's 70. And then our x to the other side, minus 5, so x equals 75. Okay, so 2 times 75 minus 5, so 145. So this measure, this exterior angle is 145 degrees. Okay, find the measure of angle DEF. So see, you can see they've moved this exterior angle and my linear pair. So the exterior angle is this one right here. Here's the other angle that matches with it to create the linear pair. So that means then these are the interior angles, that 3x plus 6 equals the sum of those 2. So 3x plus 6 equals 35 plus x plus 25. So we're supposed to find the measure of angle DEF, the exterior angle, so we'll combine all our like terms. So 2x plus 6 equals 60. Subtract our 6. So 2x equals 54. Divide by 2. So x equals 27. So if we want to find that measure, then we're going to say 3 times 27 plus 6. And it should give you 87 degrees. Okay, new theorem, mid-segment theorem. So that one says the segment connecting the midpoints of two sides of a triangle is parallel to the third side and half its length. So if you take this side right here and you find the middle of it, that's what the mid-segment is. So here's the middle. These two pieces were marked congruent. That means that's in the middle. And then you do the same thing on the other side. Take this segment, find the middle, should be right here. Connects this piece to make this one equal, so those mid-segments. So if you connect this line, this one right here, and the base right here, it turns out this top one is a half the measure of this bottom one. That's true. Okay, so we've kind of oriented it different, but I'm looking at this and I can see that this is in the middle because of the markings, and this point right here is in the middle. So I actually know that y is half the length of 20. So y is 20. That was the easy one. The other one, the 2x and the 2x plus 36, okay, those angles aren't equal. So this angle right here, because it's, or excuse me, this segment, because it's connecting the midpoints and this is the base, it also said that theorem said they were parallel. So these are considered parallel lines. So these two angles right here are considered consecutive interior angles. So consecutive interior angles with parallel lines are supplementary. They add up to 180. So if we want to figure out what x is, we've got 4x plus 36 equals 180. Subtract our 36. And then divide by our 4. So x turns out to be 36. Okay, here's another one. It says DE is the midsegment of triangle ABC. So I know this is the middle since this is a midsegment and this is the middle. So this segment right here, y plus 3, is half the length of 2y, or excuse me, 4y minus 8. So if I double the y plus 3, that should be the same length as the 4y minus 8. They would be equal now. So we get 2y plus 6 equals 4y minus 8. Combine our like terms. So we end up with 2y equals 14, so y equals 7. Okay, and on the other side here, because I know that this was a midpoint, this piece right here and this piece right here, the 3x plus 2 and the 5x minus 8, they're equal. So to figure out what x, I'll just put those equal to each other. 5x minus 8 equals 3x plus 2. Combine my like terms. And x equals 5. Okay, so those are a couple other theorems that are helpful when you're solving some geometric problems.